Yo, yo, yo. What's up? What's up? Welcome back. Today we're working on my OpenGL renderer that we're making for like a stream intro screen. So this guy is currently displaying as like a pre-screen for when stream starts. And it's like this like kind of like programmy thing where we have like it like pretends we're running an executable and pretends we're like typing in how much time until the screen start or the stream starts, whatever. For whatever reason, doesn't really matter. But we wanted to use this as an excuse to explore 3D rendering. So we've kind of like constructed this scene where we have like a CRT and he's like in like kind of like a depressingly lit room, like shitty office vibes from like the 80s, and like he's got this like what we were trying to actually say to the world is going to be sitting here on the screen of the CRT, and we can like adjust this the same way that we're doing this now, but like it'll be updating on the screen. And maybe we have like some like CRT effects to make it look like a little fancier, and maybe we add like a little bit of flavor with like like some like shit on the desk, like papers and a coffee cup or whatever. Doesn't really matter. But where we're at right now is we have like our 3D geometry loaded and rendered with OpenGL. And we have like some like camera movement here. We're rotating the camera around the scene and we're seeing that have an effect. And we have also see like a light rotating around the scene with us. So you can see like kind of like the back end, the right side of these objects is kind of getting darker, or like the close right side is getting darker. But they're not casting any shadows, which is kind of lame. It looks like weirdly flat. Some of that can be fixed with like texturing, which we have support for. But what I want to see is if we add shadows, does it look a lot better? Right? Like I want to see like some sort of like this type of thing where the shadow is cast on the table by the objects or by the lights. And so we were looking up like how do we do shadows, and it looks like what you're supposed to do is you render the scene from the point of view of your light source, and then you have a depth buffer basically from that process that the GPU has generated, and that you can like sample that depth buffer for each point in your scene to like check if you're deeper or less deep than that specific point. And so we've been kind of like getting to that point. Hold on, let me get to the latest and greatest. Well, I guess saying the latest and greatest isn't quite right. The latest and kind of broken in lots of ways code, but we can kind of show it here. So this is us rendering the scene as a depth cloud and then displaying it on a plane in the scene. And so what this is proving is a couple things. One, if we look closely, we can see like some variation of lighting on here. It's very, very faint, but that indicates that we are seeing correct depth here. This is a depth buffer. And we've rendered this not to the screen, but to a texture, and then we're displaying the texture later. So that proves that we like have the depth information. We have it in a way that we can access it from the shader. And so now all we have to do is when we render the scene normally, we have to take that information, sample it, and do like a transformation of the points from our perspective or in the world to the light, and then sample the difference. And we can use that to apply like a difference in lighting. So yeah, let's just get into that. And so yeah, where the steps are: get like light transform in the shader, get texture to the shader, compare depth, and then we've kind of left like a wake of destruction here. So likely we're kind of at a point where we should do some cleanup and committing and stuff. So let's just get moving. I guess actually the first thing we're going to do before any of this is put the scene back into a sane state. Because we kind of left some like bullshit in there yesterday. So let's go to our like render section. This is like pretty hard to like parse right now at a glance, but basically there's like two render sections. One is like we bind how do I say this? A texture as like the thing that we want to render to. So you can render to like the screen, or you can render to a like image. And so here we're like render to this image. This is like the setup for all of that. And then we will clear the screen and basically set our camera up to be at the same direction as where our light is coming from. Is that true? Yes. No. Yes, it is. we see here is kind of hidden behind the like screen thing. But we're basically saying like, hey, look at the light direction. And we render the scene orthographically, and then we like kind of like scale the world down so that we fit correctly on here. Then we like render the scene, blah, blah, blah. Render all of our objects. And then we clear all of our like rendered texture state, and then we render the scene again, but from the position of our camera. And here we're doing some like bullshit here where we are rendering the texture to a plane instead of like leaving it around in the background. So let's just undo that. And I think we should now have like something kind of sane. We should put our camera somewhere that's like a little nicer. So let's put our camera at, I guess we'll rotate it with time like we were doing before. So we'll do like float cosine the time and float sine the time. Oopsies, F32 sine, not float sine. And we should see the camera like rotating kind of nicely. We have our up direction is kind of wonky, so let's fix that. We want that to be world up should match our camera up, so up is up. Cool. And then yesterday we replaced like our monitor with these axes so that we could like do some debugging. We don't need to do that anymore. So let's just pull the monitor back where it's supposed to be, which is going to be over here. We had monitor and monitor. Okay, I think that's good. We also replaced the table with a plane, and we want that to be table. Just for debugging yesterday. Okay, so now that's pretty reasonable. I do kind of want the camera to be a little lower. It doesn't really matter, but I can't help myself. I do want the camera to be a little bit closer to the table. So like maybe like 0.65 or something, maybe 6. Let's just see how that looks. There, that looks a lot better. I'm okay with that. Happy with that. Okay. So we're in a sane state. Nice. Now let's try to start getting some info about the light into the shader. So previously we were using a light direction, which is pretty reasonable. I don't know if like using a light direction and a light transform together is too much, but for now what we'll do is we've basically taken the direction of the light and turned him into a transform, like a 4x4 matrix that we apply to each vertex in the world, and that will put the vertex in the perspective of the light. And so what we can do is we can just say let light transform is equal to this. How do I, let's find this. It's everything in these brackets, I guess. So this is a transform, transform, transform. And we can then use the light transform here. And then when we do our like second render pass, we can say self mesh renderer set light transform to be the light transform we just used. Which we then need to like get into our shader somehow. So we'll look at our vertex shader and we'll say one of the many inputs here is going to be something that's the same for all vertices, a uniform value, and he's going to be a 4x4 matrix. We'll call light transform. And we won't give him a default value. Maybe we'll give him a default value of identity. Ah, fuck it, I don't care. And I guess what we're going to do is we're going to pass on to the fragment shader our depth, the depth of our vertex from the perspective of the light. And the idea is there that we will later also have the texture that says how deep each pixel is we can compare. So we will say, we will propagate to the fragment shader the depth, so only one dimension, we only care about z, the depth of our pixel from the perspective of the light. So we'll say light depth is what we'll call it. And then we'll just say at the end of our fragment shader, for each vertex, we will say that the light depth is equal to our input vertex multiplied by the light transform. And we just care about the z component. And I guess that's not quite true because we care about the z component over the w component, because the way that they like structure these guys is they have 4 element arrays that go like x, y, z, w, and these guys, when you want to like render them in 3D space, they're converted into like x over w, y over w, z over w. So we actually want to say that the vec4 light, or vert light space, I guess we'll call it, is equal to this transform. And then the output here is going to be the vert light space z over vert light space w. Bing, bang, boom. Ready to go. Then in our fragment shader, we're going to do something like in float light depth. And for now, let's just multiply everything by light depth so that it doesn't get like compiled out, and we'll fix it later. I guess we can even do something clever. Like we can say, take the max of light depth and 1.0, and then take the min of that and 1.0. So that's what we're kind of like essentially tricking the compiler, hopefully, into just using the value 1.0, but without optimizing out light depth, because that'll fuck up some of our like code in our Rust side of things. Okay, so let's just try to compile and run that to make sure that that still compiles. Great. There's also a bunch of like ugly, there's some like prints here that are just like fucking spamming the screen that are pissing me off, so I'm just gonna disable those real quick. I think there's another one that we left in yesterday in the lookat function. There we go. Yeah. All right, there we go. Much better. And our shaders are still running, which means that all of the modifications that we just made to the vertex shader and fragment shader are like compilable, at least. And let's go back here where we were trying to inject the light transform into our guy. And we just have to make that function. So we'll copy paste the set camera transform one, and we'll say set light transform, and he does the same thing where he sets up a program and he uploads a 4x4 matrix, but instead of uploading it to the view location, he's going to update it to the light transform location. Which means that somewhere we need to like look up where in our shader that is, where we have all of those guys just kind of sitting here. So we can just say light transform location is, what do we call it? We called it light transform in the shader, right? Vertex. We called it light transform. Nice. Nice. Okay. All right. And then we just write that guy down. Light transform location is this. And we say that we want to keep track of that guy. So say light transform location is that guy. And I think now this should compile and still run. No problemo, but it doesn't because we fucked up. So he doesn't like something. Probably here, line 97, he's saying that there is no thing light transform, which is fucked up. Did we spell it wrong? Light transform? No, he's fine with that. Out, float, light depth. It could be that our like hack in the fragment shader was like too shit, and it didn't realize it, like figured out that it could compile it out. So let's just multiply by light depth for a second to see if that works, and that does. And that's kind of interesting here too, because you can see that we're now getting some sort of darkening with distance from the light, which is kind of indicating that we have the right thing in there, which is pretty good. It's pretty sick. All right. Next up, we shove the shader in there, or we get the texture in there. So we rendered the depth to a texture, and now we should just be able to say, let's also take in our fragment shader, sampler 2D, a 2D thing that we sample, and we'll call this light. We can't call this light depth. We'll call this light texture. And so probably all we have to do is just check our value and the value in there. So we'll sample the texture. So we'll say light text depth is we sample light texture with our UV coordinates. No. What are we sampling him by? I guess we're sampling him by our X and Y position in light space. Which means in our vertex shader, we actually don't just want to put out the light depth. We actually want to put out light position total. And here we will say that our light position is going to just be, maybe we'll just give him the whole vec4 and let the fragment shader do the work of the division. And then all we have to do is say light position, which is also probably already something that we named. Nope. Okay. We'll just call it that, which is just the transform that we applied. And then in here, we don't have in light depth, we have in light pause. And our texture coordinate for these guys. So what we have is like we have some sort of like coordinate that we've mapped into the OpenGL world, boom, 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 which is essentially just a cube, right? In OpenGL, you render the world in this like -1 to 1, -1 to 1, -1 to 1 space where like everything's normalized. And our texture coordinates are going to be like one of these, like looking in this way, but mapped like 0 to 1, essentially, instead of -1 to 1. So we can take our like X, Y positions, probably, and then convert them to texture space. So we can say like float OG, normalized, I think it's normalized display coordinates. What do they call them? N something C is the word I've seen before. OpenGL NDC space or something. It might be, somebody will tell me if I'm not using this right. NDC space is normalized device coordinate space. Nice. So we can say NDC to UV. Sure. We'll take in a float. And we will return a float, which I almost did Rust syntax here because it's so built into my fucking head. But that's okay. And we'll just say return. So we're going from -1 to 1 to 0 to 1, which is simply add 1. This should have an input. So val plus 1 divided by 2.0. Bing, bang, boom. Easy. Easy, easy, easy. And so here we can say, maybe we also want to be able to do this for like a vec2 so that we can, in fact, maybe we only really want to do this for a vec2. I wonder if there are like generics in GLSL. That'd be kind of cool. That would be cool. Yeah, okay. That makes sense. So they do it with a preprocessor macro. So define NDC to UV template, and we take in the type. And they're basically saying then you just do what we did here. But instead we shove a little type in here. Bing, bang, boom. Now, all of a sudden, we should be able to define this for both floats and vec2s. Maybe. We'll see. It's kind of funny because we're only ever going to use this for vec2s, so doing it this way is kind of silly, but whatever. Okay, so we're going to sample the light texture by our light position XY, move from normalized device coordinates to UV coordinates. Sick. Sick, sick, sick. And then we just check if our light depth, the depth, or our depth is deeper than that. So we say if, or we'll say out color, probably, XYZ times equals, I guess we'll say like, is lit. It's so lit right now. It's so lit. If it's lit, is lit. Sorry. We actually want float lit multiplier, I guess is what we want. And we'll say if we are deeper, so light pause dot z over light pause dot w. We are going to check if this is higher or lower than what we see in the depth. So if this is greater than light text depth, and I think that we can probably just look at like one of the channels, because it should be a grayscale image, so R, G, and B should all have the same value. If it's greater, then we say no light please. Otherwise, we say yes light please. And we just multiply this by lit mul. It's so lit right now. Does that compile? Nope. Unexpected return at line 19. Fine, we'll just do it with vec2s. Oh no, we just didn't put a semicolon. We also didn't escape these new lines. We can still do it that way. Noise. Syntax error, unexpected thing, expected other thing. That's interesting. Maybe I have to do like that, because I had a comment in there. Unexpected bracket, expected semicolon. Do I have to put a semicolon here? Line 24. No. He's mad. He's mad. 35, maybe. Oh, maybe that was all reasonable and he's mad at this? No. Okay, we'll just take out this fucking macro. We don't need it. Oh, unless it's this. Unless, just one more. I can't help myself. Yeah, fuck the macro. We only have one type we care about this for, so like, why are we doing this extra work? Because we're fucking idiots. Vec2. Vec2. Run. Okay. Light text depth undeclared. So we have to give this guy type, which is going to be probably vec3, I think. Vec4, it's actually vec4 because there's an alpha channel in there too. Okay. So we have something. We probably didn't set the texture, so we're just getting like a hard line at like some fucking random ass position. So let's then go into our texture. Nope, into our render. That's where we're going. The place where we set this guy up. And one of the many things that we have now is we have not just the light transform, but the light texture. What did we call it again? We'll look in the fragment shader, compare. We have something called sampler light text. That's this guy. Light text. And so we'll say light texture location. This guy gets shoved into our state for this program. And that means that here we need to write him down here as well. Light text location. Boom, 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 boom. And then we copy paste this other function. So where were we? We were setting light transform, and now we'll just set the light texture. So input will be a texture that is probably of type native texture. Here, instead of uniform matrix, we're saying uniform text. No, we set a texture somewhere, so we can just copy that. We just bind the texture. Interesting. So we know that the light texture is the second texture in here. So we can get a little tricky in here and say bind texture 1 with the texture. I think. Seems reasonable, but we'll see. I actually don't know. We're just guessing. And then over here, before we do anything, we can say self mesh renderer set light texture to our texture that we rendered, which I think is just called text here. Not good. Not good at all. So what might be interesting is to let's not do this like lit mul thing, can we just check the depth and the texture maybe at that location? That might be interesting. So instead of doing this, we can say times me by just light text dot r like this. And that should tell us, okay, so that actually doesn't tell us jack shit. Let's set the light color to 0. Does that help us? No, that doesn't help us. I would think that the light color... Oh, we set the light color externally. That's why. Set light color. Can we set it to, like, 0? If we do that, I guess our whole scene will just be, like, fucking black. But we can then, instead of multiplying here, we can add our depth from the perspective of the light. Okay. So that's something. Right? For each pixel, we're saying, what was the depth of this thing when the light saw it? And what's interesting is we're kind of seeing, like, distinct colors, which I wouldn't expect to see. Can we turn the light back on? I forget already what the light looked like. So we can set light color to 1, 1, 1. And we can just make this, like, very irrelevant. I just want to see what the color of the light looked like. Okay, so the light's, like, above or something. Let's set, like, a static light position, just so that it's, like, a little clearer. So self.lightdir. Lightdir. We are rotating it with time, it looks like. Where did I see that? Here. And so let's just not do that, and just say that the light is always coming from -1 point, or looking towards -1, -1, -1.0. Unconditionally. Okay, cool. So now we have some sort of, like, static light setup, and we can go back to looking at our shadow map thing and see how that looks. So actually, let's just go back to looking at, like, what the texture says. Okay, so that seems like it's saying something reasonable, I think. Maybe. It's hard to tell. So let's go back to multiplying by... what were we doing? We were checking our light texture. We're checking our position, so... This is the depth that the texture has, and we want our position. So we say, light pause dot z over light pause w is greater than this. If so, 1.0, else 0.0. If we are deeper, no, if we're deeper, there's no light because you hit something else. Otherwise, it's bright. Fuck. Okay. So we're just getting, like, a hard line. Is that even in, like, the same direction as the light? We might be hitting this same thing where the depth is being interpolated with perspective on and fucking stuff up. Let's think about this. No, I don't think it should be doing that. Can we just multiply... I forget if we did this already. I just want to multiply by the depth that we are seeing from the light texture. And we're getting invalid vertex here because like the fucking GLSL thing like optimizes stuff out. Can we like disable that? GLSL stop optimizing out variables. It's like fucking annoying. Inactive uniform determination is not optimized. It's a consequence of how unextended GLSL programs work. They are compiled and then linked together, and because of the implementations know exactly which paths contribute to the actual pipeline output. Some implementations are smart about this, blah, blah, blah. So we just have to handle the fact that some of these things aren't going to be there. Fuck. Okay. So what we're doing is we're kind of like unconditionally expecting all of these parameters to be there. And the reality is that depending on how we use them in our program, they might not be. And so what we should do is just for each of these guys where we're like writing down where they are. Oh, light text location is never read. Hold on. Maybe we just fucked up our copy paste. No, because we expected to use it with active texture. And I forget if we ever tested that texture looks right. I think we did. Okay, sorry. Let's go back to making sure that like when things are not used, they don't like fucking crash our program. So basically, all of these guys will just write down, hey, I am an optional thing. So we'll just do that for all of these guys. We'll go option, and then go to the end, and then go to the next line and say that again. Boom, 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 boom. Right, like this. So they might not be used. Then everywhere we tried to get a uniform, we just don't do this expect. Boom, 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 boom. And everywhere we try to set a uniform, we just say, oh, nice. We don't even have to do anything here. We can just, instead of wrapping everything with some, we can just write as ref here, and everything should just work out. We should have just done this from the start. This is way nicer. Way nicer. Okay, like this. This guy's also as ref. As ref. As ref. And we can probably even get crazy here. We could do like some fancy search, but I'm not going to. Okay. And one more. Okay. Now when we run, hopefully we don't crash. And now we are showing the depth that we saw. I think we're multiplying that in. So that looks like our texture is bound correctly. If we didn't bind that texture, right? If we didn't do that, we wouldn't see that nice gradient. Oh, we are seeing that nice gradient. What the fuck are we doing in our shader? We are... Oh, sorry. That's just our position from the perspective of the light that we're multiplying by. Great. Which seems like it's reasonable. Right, we're seeing from the perspective of the light, things that are farther away are getting darker. Versus if we didn't do that lit multiplier. If we didn't do that, we just see like normal shadows. And so just to double check, the light is coming from the front right of the desk. And if we look at our lit mul, we are... Oh, wait, this is maybe wrong. So the light's coming from the front left of the desk, but we're seeing... We're seeing our depth relative to the front left of the desk, right? We're seeing brighter on the front left when we multiply by our depth. But the light's coming from the front right. Right? Because the shadows are at the back left. So what's up with that? It looks like maybe one of our transforms, maybe our light transform when applied to the world is actually wrong. But if it's wrong and consistent with what's in the texture, that might be okay. Because we're still doing the same transform that the texture's getting. So let's multiply by what we see in the texture. That seems reasonable. And do we see the same thing that we saw when we looked at our depth? And the answer is no. We're still seeing dark at the left. Let's turn off the light completely and just multiply by the texture depth. And so the texture depth is showing deeper at the back left, closer at the front right. Is that true? Yeah. I think so. If we don't do this at all. Oh, shit. Sorry. We were still applying the light. I'm an idiot. Oops, he doesn't like that. Invalid vertex shader. We have to give the same treatment of deleting these like optional things to our input locations as well, because they're too smart for us. So we do the same treatment here where these guys are all also optional. Like this, and then for each of these guys, we can just say if let sum vert loc is equal to self vert loc, then we do this part. Otherwise, we don't. Like this. Boom. Boom. Cool. If let sum self or if some UV location is equal to self UV loc, do this part. Boom. And if let some norm loc is equal to self norm loc. Boom. Bing, bang, boom. All right. Does that compile now? It does. And okay, so now in our fragment shader, we're multiplying by the texture depth, and we're kind of seeing just like totally flat lighting, which I don't think we should see. Or I would think that like I would think we should see like the monitor maybe be the same color. Hold on. Let's only show the texture depth. So if we just show the texture depth, we are seeing that the monitor in general is like brighter than the table, which might make sense. Can we put the light like on like just completely left side of the screen, like on the side of the table? And I want to see like a gradient of the light as we get from one side to the other. If I understand this correctly, that should work. So let's set the light position. Light position. Light dir. Here we go. So somewhere we set this guy to -1, -1, -1. And let's just set him to like completely fucking sideways. Right? So he's got a positive X and 0 everything else. Full X, baby. Let's make sure that everywhere that we care about is using that guy. So we're using him here. We're using him here. Okay. And we're still seeing not what we expect. It almost looks like we are still using the color texture here in some way. That's how it feels to me. So let's go back into our fragment shader and double check that we're not doing something fucking stupid. Let's think. Let's not do this. And we'll make this a vec4 with an alpha of 1.0 no matter what. Sorry, like this. Okay. So the fact that the monitor is brighter than the table is like 100% wrong, right? If our light is coming in sideways, we should see that the desk at one point is brighter than the monitor. Okay, so what am I missing? We can try looking at different channels of this guy. Maybe R is not right. Oh, interesting, interesting. Interesting. So why is that behaving differently? Red, green, and blue from our sampled texture is not what I expect. Interesting, interesting, interesting. Let's just see hand wavy. If I switch the order of these textures, like, why am I seeing the same behavior? Set light texture. Oh, we're not even doing anything. So what the fuck is it looking at? Okay, I don't understand something. We're gonna look up bind texture to uniform OpenGL because clearly we don't understand something. Texture unit the sampler references. So in order for a texture to be referenced by texture var in the shader, it needs to be bound to texture unit 0. So here he's saying you set the uniform. Oh, so you have to set the uniforms to the texture you're using. So we can say self gl set uniform. What is it? 1i. We set the light texture location to 1, and then we use texture 1 directly. And so we should actually have to do the same thing when we bind the texture of the mesh as well. So this should be, maybe they default to 0 or something. Okay. That is definitely something else. Definitely something else. It doesn't look at all fucking right. But it's something. So we've made progress. Texture 1. So if we say we don't do this, we get nothing. And here we do bind this. We get something. Okay, fuck yeah. Fuck yes. Okay, so now let's go back and look at like if there's a difference between R, G, and B. No. And I'm also noticing that like the things are not kind of staying in the same place on the objects. So it's possible that this like NDC to UV is not working correctly, and maybe because we have to divide this by light pause W for it to be valid. No. Okay. Can we, or should we be seeing any gradient or anything? Let's move the light around. Like, let's set the light to be up in Y as well. Okay, so we're definitely seeing something, right? And you can almost see, like, there's, like, you're seeing, like, the edges of these objects, but, like, incorrectly mapped, which is also interesting still, right? Because we would expect that if we got our mapping of light position in our shader to the texture correct, we should see like lines in the world should line up with lines on our object. Which is interesting. So we have this light transform, and we multiply by the input vertex. We are using that position. I wonder if we should be doing any like device coordinate mapping here. Let's see what happens if I just use my XY position directly. Doesn't seem any more reasonable. It does not. I'm pretty sure when I think about that this makes sense. This like UV mapping stuff. Can we maybe print? Maybe instead of doing this texture mapping, can we set our red and blue colors of our output? Let's just see what the light position is. Yeah. That seems reasonable. So we'll say light pause dot xyz over light pause dot w, and that should render in like where in light space we think we are. And I think this is making sense where we're seeing fuck. It's hard to like think about with these so many colors. So can we do like just X? Let's just only look at X. And so in light space, our X is going from the left to the right of the table. And maybe there's like a little bit of an angle on there. Let's go back into our main and set our lighter to be completely horizontal in the world. Or completely vertical in the world. Let's do completely horizontal. Okay, so now we're seeing light positions that align along X, which is good. I'm going to actually turn off perspective because I think there might be some bugs that are arising from like mixing and matching perspective and non-perspective. Here. Okay, so there we go. So we have like this like nice linear mapping of left to right, white to black, and we're seeing like 1 to -1. If we wanted to see 0 to 1, we should be able to go into our fragment shader and do that like device coordinate mapping to this guy. So we can say float, use floats here and do NDC to UV this. There we go. We see this like nice bright to dark mapping along the whole area, which seems good to me. So I think that we can be like fairly reasonably confident that our X position on here is right, and our Y position should just be going top to bottom, which we're also seeing. So I think it's reasonable to assume that our light position mappings are working correctly, right? If we set our light to come from the top instead, light position, or lighter is what we called it over here. Hello? Where am I looking? Here. Or maybe let's put them in Z instead of in X, because I'm worried about, like, world up bullshit. So our Y is still the same. And if we render our X position again, we should now see it going, like, the other way, front to back. So all of this seems pretty damned reasonable. Which makes me think that our, like, light coordinate mapping is making sense. And so let's go back to trying to look at what we see in the texture. So we could say light text depth XYZ. And here we're just seeing fucking bright as shit. It would be interesting to like maybe divide it by like 10. Let's just try to like get it in like a range that is like not completely flat. So that's like pretty dark. Maybe can we even divide by like 50? That's always dark. What am I trying to figure out here? I'm trying to figure out if we can like see any change in the world by rendering the color of this guy. So I don't know, man. I just want to see any gradient at all. Or any, like, change. Which I'm not seeing. Let's go back to rendering the light position and put the camera, so put the light somewhere that creates, like, should create a reasonable shadow. Maybe. Maybe. Let's think about that. That seems reasonable to me. So go back to showing the light position XY and no Z. Okay, so we're seeing X and Y, and let's go back to the other way. So it's along X. So that we have a maximum change of depth from the perspective of the light. Oops. Is that right? Set light dir 100 should mean that we're moving along X. Yeah, I don't see any other assignments here. But here I see X is along the long way. I want X to be along the short way if my light's coming from... Am I high? I think what I'm thinking is if I'm saying that I want my light, if this is like my table, and this is X, Y, Z, if my light's coming this way, my red should be like this way. I feel like I'm high. Maybe it's the other way. Let me flip the red light around again. Where was I? Here. So here. Okay, so this is the way I want. I want the long way. So if I show Z here as well in my light position, I should see blue increasing along the table, which is what I want. I think. I don't know, man. We're trying to understand. Yeah, okay, so we are seeing blue move along the table, which means that depth should be increasing along the table. Great. And again, just to like fucking give myself peace of mind, let's render light pause dot Z over light pause dot W in that range. Which needs to be a vec3. It is fucking bright to dark. Wonderful. So why the fuck, when we look at our depth texture, do we not see that? Right here, just fucking white. And we should, like, this guy should have the exact same fucking thing that we had when we rendered from that perspective. So, like, what's the difference? Right? What's the fucking difference? So, it could be that our light texture sampling... oops. This is not using the normalized to UV, so there's a chance that that's fucked up. There's a chance that that's the bug, so let's look at that again. Right, that's just... Oh, hold on. Hold on. If we look damn close, we can see a tiny version of this in there. What's up with that? I think there's a chance that our scale for this guy inverted. Yeah. Okay. hear me out, hear me out, hear me out, hear me out. I'm just going to invert the scale here for a second. And just let's see if that lines up. Not quite, but we're getting closer. Getting closer. Okay. So there's something here that I just don't understand. Hey, just joining, how's it going? It's going okay. We have like a depth texture for our light source, and we're trying to use that when we're rendering normally, and use that to like make a shadow. But we're misunderstanding something for sure. Okay. So why? Oh, fuck me. Are we not using the aspect ratio somewhere? When we are doing orthographic rendering, we are still accounting for aspect. But here, when we do our normalize, do we need to do it here too when we do our light transform stuff? We do. So lightpause dot x divide equal by aspect. That looks like it lines up. Okay, so there's two problems here. One is that our scale is inverted from when we use it on the camera, which kind of makes sense. In some way. Right, so when we are doing, how do I say this? When we position the camera in our system, which is like not the normal convention, by the way, just in our setup, we put the camera, we have like the world, right? We have like a box in the center of the world. And we take the camera and we say like, hey camera, go up over here and then to the left over here, and then like turn yourself to look at him. So we like position a camera with like normal translations and rotation stuff here. And then in our shader, we say, okay, now don't actually do that. Instead, when you render this guy, do like the backwards movement that you did for the camera. Just do that all in reverse. And so the camera actually ends up at 0, 0, 0 in the center of the world, and all of the world is warped to match the camera. So then if we say we want everything in the world to be half as big, for the camera, we have to say everything is twice as big so that when we invert, everything gets half as big. But when we are doing that transformation later, the scale actually is no longer, like the transform is no longer inverted. That's not right, I don't think. It should be inverted either way. So we're just not inverting when we should be. Yeah. So that's right. Inverse, light transform, invert. And then let's go back to using the same transform no matter what. Let's try that. Do we see something sane here? Yes. We just forgot to invert the matrix, but I was kind of getting there by a roundabout mechanism. Okay, so let's go back to putting the light not completely horizontal so that we can like get some form of shadow. And what I hope to see is that where a shadow would be cast, we see some sort of depth change, but that's not what I'm seeing. So fuck me, I guess. Fuck me. Here we see some sort of horizontal line, but I don't know if it's where I would expect. But we can try it. So let's go back to our multiplied light thing and just see what this looks like. Let's just see. He doesn't like that. So we can say out color XYZ times equals the multiplier. He doesn't like that because something. I don't know what he doesn't actually like there. He doesn't like that there's a type mismatch at line 28. which is here. Lit mul takes the light position, the Z position, over the W position, and says, is that greater than the sampled texture? Oh, and we just didn't sample it yet. We just forgot. Okay. And our out color should be what we sampled in the world. So here we can just say out color. And then we multiply it by whether or not it's lit. And here we're seeing nothing of value. Fuck. Fuck, fuck, fuck. Okay, so we're close though. We were close because we were seeing that our light texture does line up with our geometry in some way, which is a really, really good sign. We just have to figure out what we're missing otherwise. So light, text, depth, XYZ. I would like to draw the light again, actually, because I want to see where the light is actually supposed to be coming from. So we can do this. What is it supposed to fucking look like? So I think we can just do like this, I think. Cargo run, let's take a look-see. Here our light is coming from like left and bottom, or left and completely sideways. What the fuck? Lighter. He's confused in some way. Oh, we want negative here, so he's coming from on top. That's better. So we had our directions kind of not the way we wanted. Okay, so now let's look at the texture again, which I guess is going to be in our fragment shader. And we go back and we set the out color to be what we sampled from the texture. Light, text, depth, XYZ. Okay, hold on. So I think if I'm looking very closely, we can see a shadow cast here because the depth here does not match the depth of its surroundings. And so, if we then multiply this by lit mul, just to see, no dice, but we're close. We definitely are close, because if we say, instead of rendering this, we render our Z position. We have to wrap this in a vec3. We see the same kind of like movement here. But it looks like it's getting brighter where the shadow is cast. So it could be that we need to do a lit mul to check if this is less than the value we see in the texture. Maybe. So we'll just say times lit mul here. Just to see if that does something useful. Nope, that's just fucking dark everywhere. If we do greater than, it's just bright everywhere, except for like this tiny bottom corner shit. Can we just set the color to be vec3 lit mul? I just want to see. We want to see like a mask that matches the depth, and we just don't see that. But we know that the depth texture that we're reading from, we know that it has something, right? If we do like light, here we do light text depth R. We know that there's something going on here. Let's like multiply it so that we can see the difference better. Too much. Maybe multiply by 2. Maybe. Too much still. Maybe we want to do like minus 0.2 times 2 or something. Or maybe we'll just do minus 0.2. Minus 0.2 times 2. Right, like we're clearly seeing some form of shadow if we look at just the depth from the perspective of light. And we're seeing that the texture that we're looking at is brighter in the front right of the desk, to the right of the monitor if you're looking at it from the screen. That's the brighter side. So now the question is why, when we try to mask that with the depth that we've computed, is that different? Right, because here we can say, instead of drawing this, we can draw the depth that we're computing. Light, text, our light position that we got, his z position over light pos.w. Right, we're seeing a similar gradient from front to back. But interesting maybe is that his minimum and maximum values might not be the same. The light pause is the position of the object in light space, not the position of the light in object space, I think. So if light is coming from like the front right of the desk, it's like, how far are we from that? And I guess this looks like, if we just like eyeball this, it's in the range of -1 to 1, because we're seeing like a bunch of black at the back of the desk. And I guess it's possible that the texture, if we don't do any like funky like white warping, scaling, whatever, he's clearly in like a different space because he's just all gray, even though we got here with the same values. So it could be that the depth buffer just has a format that we don't expect. And it'd be interesting to see, maybe it's in like the range of 0 to 1. So if we multiply this by 2 and then minus 1.0, do we see something that looks similar to what we were seeing before? This is maybe, no, this is not the same. So maybe I need to do some we could always just look up an answer. We could read. We could look at advanced lighting here and look at shadows. Because here they do the same thing where they use the depth buffer and they use this in their shader. And is there some sort of like funky math that they have to do to convert the shader space back to like the thing they're sampling to the same range as their light transform? So they are projecting the coordinates, doing the same thing that we're doing, right? We have our position in light space, and they are then doing the same thing where they're converting it into UV space, checking the shadow map, looking at R, looking at their current depth, and looking at the closest depth. So they're not doing anything crazy, right? They are just looking at the depth from the texture and being like, oh, it's bigger. So maybe it's more about how, maybe it depends on how we bind to the how we bind our texture when we bind our depth texture when we render from the point of view of the light. Maybe we need to set some parameters on that buffer so that it's working in the same space. This looks promising. So they say, hey, please use floating points here. I bet we didn't do that. Let's look at our parameters when we set this guy up. We use unsigned byte. 255 unique values. If we say, hey, you can be anything you want, any number, as long as it be represented by a float. Does it look different? Let's go back to not doing this scaling here. Let's just look at the value. Nope. Oh, it was worth a shot. I was hopeful. I was hopeful. Are you projecting my light XY as well as Z? I think so. I think so. Let's see. Why the fuck is an ad running? Fuck off, Twitch. I guess I'll just snooze it for the maximum amount of time. That's annoying. So if I understand what I'm doing correctly, I've taken my light transform, that is the exact same transform as I used when rendering orthographically, and I am applying that same light transform in the same way by the input vertex. Oh, this is just not the same. Hold on. Let's just make sure that we're doing the same fucking transformation. Oh, I guess lucky for us, our model is always in 0, 0, 0. But then, we also have to do this scaling. What am I thinking? We just have to do the same thing here twice. So here, we know that we render without perspective. So here, all these things that we did to outvert, we also have to do light pause. For sure. For sure. Otherwise, we're just in a different coordinate space. Hold on, hold on. Nope. Not quite. Not quite. Outvert is equal to invert. Then we do invert times model times the inverse of the transform. I guess then I guess we are not doing model transforms here, actually, maybe? I'm not sure. No, we should be. Then we divide xy by z. Oh, we're in this case. Sorry, we're in the else case, not the perspective case. Here we go. Here we go. Light pause. Okay. Which didn't seem to do much of anything. But we can go back to that times 2 divided by -1 to put us back to see if it's like a 0 to 1 versus -1 to 1 thing. Could be. Could be. Can we look at litmol again and see what that gives us? Everything white. Doesn't look like the xy gets divided by w in the fragment. That's true. But when I look at it seems like my problem is with z. Because how do I say this? Because when I look at the texture that we're getting out, like, the shape of this makes sense. We're mapping correctly onto the object that we're looking at. We're just like the depth values that we're getting are like fucked in some way. Oh, hold on. Hear me out. I'm just gonna multiply this by 10 for a second. And no, that's not what I'm gonna do. Fuck me. What am I missing? I have to think. Use my head. Use my noggin. Think. Like Winnie the Pooh in that movie I watched when I was like 4. So if I'm flipping back and forth between things I've done before just to try to like freshen my head. So here, this is what it looks like if I render, what is this? Just the position that we're getting as our input z here, which makes sense. Now, let's go back to rendering what the texture says. How is that different? He's just overall fucking brighter. And we already theorized that he might be in the range 0 to 1, where our input coordinates are in the range -1 to 1. So we already said, what happens if we times this by 2 and or divide add 1 and divide by 2 to get us back in the range. We already said this. What happens if we do that? Oh, hold on. This might look more like... Hold on. This is our light position. This is the depth texture. Those look the same color. Okay, so maybe it was the 0 to 1 thing, as well as that like divided by 10 that we forgot to do in our fragment our vertex shader. Right here, we just forgot to apply the same thing that we did when we rendered from the perspective of the light. So maybe now this lit mall actually makes sense. So let's say lit mall. We should see a dark area, but that's not happening. So it also could be that there's like some like quantization going on. So we might need to like bias this a little bit. What happens if I like subtract 0.1 from here? Still too bright. Minus 0.2. Oh no, sorry. I want a plus to make it dark. Everything's still white. But that's because I didn't do the scaling. I meant to do this. I forgot to do the, I guess we just do the NDC to UV on this guy. But that only works for float or for vec2s. So we'll just define this again for floats temporarily. Copy paste it, write float here, and convert this from NDC to UV. There we go. Okay, that's looking promising. Everything black. Let's go back, remove this +2. Oh, let's fucking go, baby! There it is! Okay, so our understanding was wrong about several things there. One, we needed to make sure that we were applying all of the same mappings that we did in the vertex shader when we render. We need to make all of those same changes to vertexes that we are using with the light transform. And then 2, the depth buffer that we rendered to is in the range of 0 to 1 versus what we have, which is in -1 to 1. Now, it's kind of crazy that it took us an hour to get there, but that looks fucking sick. That looks sick. We're also noticing here probably that like we're seeing some sort of like weird like artifacts there, and I'll bet you that there's just some sort of like we need to probably add like a very slight bias to our depth. That was not slight enough. Very slight. Not slight enough. Or maybe we needed to do a less than or equal to instead of a less than. Still fighting. Let's try adding a very slight bias. Maybe just adding a slight bias is not right. Maybe we need to say if he's... Oh no, that seems reasonable. Do I just need to make it even slighter? Oh, Twitch compression is not loving that. Let's see. Oh yeah, he's having a field day. To be fair, it doesn't look much better on my screen. My screen also thinks it's shit. Could work off abs difference. Yeah, that seems reasonable, right? Because I can't just like set a threshold to introduce bias. Yeah, I think you're right. That's pretty, you know, no matter what we're doing though, that looks cool. I'm just gonna say that. Unrelated. So we should say lit mul. Wait, is that true? Absolute difference. Let's draw this out. What am I drawing? What am I drawing? Sorry, my head's just not working quite right. So if I say that I have some value, say my texture depth is like equal to my actual depth plus or minus some epsilon. But sometimes my texture depth is much lower. It's like way less than the actual depth. Right? Because there's something in front of us. And so I guess in that case, we should be able to, we shouldn't even need to have like a slight bias. We should be able to get away with like a large bias. There we go, I was just biasing the wrong way. Nice. So it looks like that's a pretty good, clean shadow map. And so now we can just go back to doing our normal light calculation, which we've kind of lost here, but luckily it's in our git diff. All we gotta do is do what we were doing before. Take the color, multiply it by the angle between us and the light, and multiply by the light color, and now just by lit mul. And we should be fucking chilling. God damn. That's so sick. Look at that. Mwah. And so now all we have to do is probably add some like ambient lighting, right? So we'll just say that plus ambient. So we should probably do like all of this multiplier. So we multiply the color by all of this and kind of maybe like set like some minimum value for ambient lighting. So we set the we pick the maximum of these two, either this or like just 0.1. It's dark back there, but not super dark. Woo! That's fucking sick. I'm happy with that. I'm so happy. Oh, that's so sick. Okay, now let's like move the light around and kind of see how that looks. Okay, so our lighter, he is going to rotate with time. He's rotating at the same speed of the camera, which is kind of lame, so I'm going to set the camera position to like a constant. So we'll just say like 1.0, I don't know, 1.0. Oh, baby. Oh, it's beautiful. Oh, I'm so happy with that. Very happy with that. That's so sick. Okay. That we took a long time to get here, right? Like usually we make like a lot more progress, I would argue, in like per stream, but we've kind of been like 3 streams in the making in this one, maybe more. But damn if that doesn't look sick. Yeah. So I think probably all of that allows us to position the light in like a static location. Put the camera somewhere where we want to look at the screen, and we're probably pretty close to something that looks okay. So let's put the camera at, we're at 1.61. Let's put it at like negative 1.61, see what that looks like. Wrong way. I want 1.6 negative 1. Specular highlight. Yeah, I should do that eventually. I agree. But I want to see if maybe we can get away. Like, how bad is it if we don't do that, I guess? You know? I may want to be a little closer on X. Oh, does it work with perspective? You're right. I totally forgot to re-enable that. Hopefully. Let's see. It's close. I think probably we're hitting that same bug before, where 1 over z needs to be linear. It needs to be linear in screen space. So I think probably if we set our z position of this guy is equal to 1 over z here, if we have perspective enabled, then we will be linear in screen space again. And in our fragment shader, we will have to flip our z. So we'll somewhere just say lightpause.z. Where we do this, we just have to say 1 over lightpause.z. And I'll bet you that'll make it look okay again. Oh, that's fucked up. That's not right at all. I thought that would do it. Oh, maybe this needs to go like that. Okay, I'm missing something. Sorry, guys. Twitch is forcing me to run another ad. I think something got, like, fucked up, so if you guys are hit with a second 3-minute ad there, I'm really sorry. Okay, I'm missing something. Going perspective doesn't change your light rendering. That's true, but it does change my interpolation within a face. So, okay, let's go back to where this was before. We'll go back to with perspective, and we won't change anything here. The problem here is that, let's move the camera around, and that should probably illustrate it a little bit. Or maybe we'll go back to perspective off. False, like this. So when the light is like on my side of the monitor, I should not see any light or any shadow on this side, right? Like this is like the correct answer, as far as I'm concerned. When I enable perspective, there's like some form of like warping going on here, right? So like now we're seeing shadow where we shouldn't. And I believe that this is the same shit that we were seeing before, where when we're like rendering in perspective mode, we have, maybe it's like, I'll take a screenshot of this guy. Hello, screenshot please, thank you. And I'll try to do it like in the bugged case, so give me one more rotation. Screenshot. Nice. Okay, so oh my god, here. Can I open this with color paint? Okay. So this table has a point here, here, and back here, and it's drawing this triangle, right? So to find the depth at each point here, it has to do some interpolation of those points. But I do think that you're right that the perspective shouldn't change my light position there at all. But there is some sort of like interpolation bullshit happening, I think, that's making it so that these shadows don't lie on the same spot. But I do think, right, that it shouldn't be on the light positions should all be orthographic. So what is not interpolating correctly? I wonder if it's just like a bias thing again? That doesn't sound right. Interesting. Because it does feel like it's not right. Maybe I'm just seeing under the monitor when I'm not projecting orthographically. Your bias will also adjust the shadow because everything is moving slightly farther away. That's possible. So what if I do no bias? But even with no bias, I feel like I'm seeing shadow where I wasn't seeing before. But it's possible that, I wonder if that's correct. Let's set the light to a static location. Like this. And rotate the camera and see if we see like shadows moving under the camera. That would be maybe kind of interesting. So here we'll do the same thing where you say F32 cos time and F32 sine time. Just to run the camera in a circle. See, something here is clearly incorrect, right? Like, where when we did the orthographic projection, it's like kind of like following the geometry a lot better. Let's go back to perspective mode again. It's almost like we have to apply perspective on the light. Is that correct? Let me think about this. So what are we actually doing here? In our vertex shader, we're taking in our position in world space. We are then applying perspective on it, and our output is like some weird, fucked up perspective mapped thing. Right? Then, completely independently of that, we're checking for each point on the surface of our object. Sorry, I was in ad break and missed all that. Okay, well, we can show it really easily here. Basically, as we rotate the camera in perspective mode, the shadows are not tracing properly. And so it's almost like there's some sort of like perspective, non-perspective shit going on there, right? Because if I go into perspective, if I turn off perspective, we'll just show this again for those who are in the ad break. Oh, fuck, wrong one. Sorry, wrong one. Here, set this false. With perspective off, the shadows track perfectly. Right, so it's like, why is that? Because I believe that you were right when you said that my light rendering is not affected by perspective. And so I would think that for each point on the surface, we should use the orthographic projection, but that doesn't seem to be true. And so that's why I was thinking like, well, if we're interpolating between these points on these faces, maybe the interpolation has to be linear in screen space with our perspective applied, which seems kind of reasonable to me. And so then there's that like 1 over z is linear in screen space thing that we discovered the other day. So I thought that if we did this and then inverted it in the fragment shader, so we can go here and we can say light pause dot, we can say light pause dot z divided equal by or equals 1 over light pause dot z, just like invert the thing that we just did. I would have thought that that should fix it. Oh, it's read only fuck. So we'll say vec for new light pause is equal to light pause this, light pause, new light pause dot z is equal to 1 over new light pause dot z, and then we can say look for light pause and just use new light pause everywhere we used light pause before. Okay. So I thought if I did this, I would get something sane, but now I'm getting something even like fucking wackier, which is weird to me because all we did was we did a inversion and invert back. So nothing should have happened. But it just means that like our interpolation is not working correctly for some reason. It's interesting. I really thought that like just doing like an inversion and then inverting back would have like all the correct effect. But clearly not. Clearly not. We also multiply by -1 when we do it over here, which is maybe relevant in some way. Oops, and we have to probably negate it in the fragment shader on the side. I would think that that doesn't matter. It's probably going to see the same bug. Yeah, same fucked up behavior. But I will note that when we do it this way, the shadow is not sliding around on the surface of the table. I think. Right? Like, I think that its shape is sticking to the table shape. No, the corner of this shadow here is probably moving under the table. Yeah, it is moving. Fuck. But I'm pretty sure that's what we're missing, is that there's some sort of, like, scaling in perspective mode that we have to handle correctly. Yeah, not seeing it, though. Not seeing it. Okay. I don't have any ideas right now, which is kind of a bit of a problem. But I think that we kind of hit a pretty good spot with the orthographic projection. So let's go back to main and go back to false here. Oops, sorry, fucked up. Something else is still wrong here. No? What did I do? Ah, fuck. I changed too much. I've lost it. No! That's this one. we missed another delete. Yeah, so I think it's pretty good. I'm pretty happy with like the orthographic projection. And so I'm gonna do some like probably some reading and maybe try to refresh my head a little bit and look at this stuff overnight. I'm pretty sure that we're like probably like 1 or 2 lines away from it working in perspective as well. I just have to like figure out what that difference is. But yeah, I'm pretty happy with this. Pretty happy with that. I think I'm gonna call it there for today because I don't have any ideas. So thanks for watching, guys. If you liked what you saw, I stream most days around 1 or 2 o'clock Pacific time. We've been working on operating systems and 3D rendering, and we'll probably be back for more of this tomorrow. I think we're so close from finishing this project off, and so I just kind of want to tie it off before moving on to the next thing. If you are watching live and you want to come back, but you don't have time to watch in the middle of the day on a work day, I have a YouTube channel that you can catch up on, so there's a YouTube link in the Twitch description. And if you're watching on YouTube and you want to come tell me why I'm an idiot, right? Come give input, fix my bugs. There's a Twitch link in the YouTube description, and you just pop by at around 1 or 2 o'clock and see if I'm live, and then we can chat. So, yeah, thanks for watching, guys. I'll catch you on the next one. Bye!